capacitors. It's a royallytic electrolytic capacitor. Ooh la la. Hey guys, welcome to an Estate Treasures video. Haven't done any of these in a while, but I still have a lot of stuff to go through, sort through, and demonstrate and talk about. Now that I've got some new display shelves and cleared some room, I'm getting back to going through some stuff that was kind of inaccessible. In particular, but wanted to do this box for a while. First off, let's get this big item, or big items out of here. So this came from the Bill Lill estate almost 2 years ago now. There was a scope there. I think it was a Tektronix 564 or something like that. I didn't get it. Somebody else got it before me, but they missed some plugins. I do believe that's where these came from, or go with, which is a shame. So if whoever does have that scope can get a hold of me, you're welcome to these plugins. This one in particular is kind of cool. Well, first off, let me take a step back. Some Tektronix models, starting I think in the 50s or 60s, were supported modular plugins. I don't have any, but I've certainly seen plenty of them online getting restored, talked about for sale and whatnot. And that's what these go to. So what they did is they made mainframes where there's a power supply and a CRT and some empty spaces where you could slide various modules into. Typically you'd have a time base and a vertical amplifier if you wanted to have a scope, or it could be a spectrum analyzer, or it could be a curve tracer, or a number of other frequency counter. This particular plugin will give you 4 traces. So let's check this out. We have 4 inputs, and each one has their volts per div, and position, and normal, and variable gain, DC balance, and all that stuff. AC, DC ground coupling with little 3-position switches. Kinda neat. Now, how could they get 4 traces on a CRT with 1 electron gun? They used a chopper or multiplexed it, meaning they would do 1 trace, then do the second, the third, the fourth, and flip back to the first. Or on some models they would rapidly switch between the 4 sequentially and do them piecemeal as a beam scanned across. I'm not sure which mode this particular one used. The usual Tektronix construction of ceramic strips with silver plated channels and all the components laid into them. And not surprisingly, we have 4 identical circuits laid out next to each other. But the cool thing is on the other side. It's a hybrid. We have tubes and we have transistors. And in particular, we have nuvistors, which are these little guys, sort of the last hurrah of tubes, where inside this there's a vacuum, and these are little tiny triodes or pentodes. They could handle higher frequencies because they were so small, they were low power. Of course, they didn't take up as much space. But inside, yeah, you've got a filament and a grid and a plate and all the usual stuff. But they could run at higher frequencies, use less power, lower internal capacitance, and that kind of thing. So they extended tube usage a little bit. Little sockets they fit into. Typically they were used in tuners on TVs for the RF front end and scopes and a few other niche applications. And they were quickly replaced entirely by transistors. So the very front end where you want your high impedance, we have tubes, and then we just go right to transistors after that. This would be early germanium types, I imagine. 2N1225. See that? Oh, these are Philcos too, at least some of them these are. I have a little growing collection of early transistor types. It's kind of wild looking. a 2N4048 Philco. Odd little construction style there. So we have some that are like that. We have some that are like this, which is a Sprague. I never knew Sprague made transistors at 2048. And then we have one that's silver. I imagine some of these are replacements. Also, early days of transistors, the quality control wasn't quite so great, so I imagine these were hand selected where they would get a lot of these and go through them and test their characteristics and get matched pairs or ones that had higher performance and use them. And finally on the back end we have some tubes, which typically you see a lot of 6DJ8s. We have that here, and 6CL6s. A couple of them over here. And then here is the edge connector. So this would slide on a rack, and they slid very nice. They have these nice chrome-plated rails. It'd slide right in, and everything was very well made, very well engineered. Let's check out the other one. I guess it's a time base. It is a 2B67 time base. Boy, a lot of positions. All the way from 1 microsecond per division up to 5 seconds per division. A whole lot of options there. And you can pull for ×5 magnification. Not sure what you pull though, it just says pull. It doesn't seem to want to pull though. Alright, there we go. It's just extremely stiff. I noticed there's a switch in the back of the control, so I was pretty sure there was a switch there. Just, man, it probably hasn't been operated in decades. Mode and calibration. Boy, aside from being stiff, these are nice controls. Tektronix, very well made. Same type of construction all throughout. Nothing has been replaced. Neat. It's a bunch of 6DJ8s, 6BL8s, 6BJ7s. Often these scopes get robbed of their tubes because they use really nice tubes. These are Amperex 6DJ8s. Sometimes you see a little bugle boy on them. And some of these scopes had a whole bunch of 12AX7s in them. So you can imagine if you've got Amperex premium quality 12AX7s, they tend to get parted out. What will I do with these two? I'll hang on to them for now, but they'll probably end up on eBay or some such. Now then, what we have here are a bunch of component substitutors. I think it's what they're sometimes called. These are a variety of capacitors, resistors, and inductors that you can hook up to a circuit and then control the value by means of a rotary switch. I've seen decade resistors many times over the years, but I wasn't so familiar with capacitors and inductors. So the deal is, you have two terminals here, can handle up to 600 volts DC or 220 volts AC, and then you can select your value. This is your coarse, this is your fine. So if I put this coarse on 0, we can go down to 0.01 microfarads, and if we put them both on max, we can go up to 1.1 microfarad. So what would you use this for? Well, that's the question I have for you guys, is what were these used for? I don't think service techs would generally use these, although you could. So say you're troubleshooting an audio amp and you think a coupling capacitor might be bad or a bypass cap might be bad. You could snip one end of it, use some alligator clips, and hook it up to this. And then go through and select. So say you had a bad 0.05, or you suspected one, you could dial this into 0.05, put this in the circuit. That seems a little impractical, because servicemen tended to be thrifty and practical, and then you could just take a 0.05 cap and hook up a couple alligator leads to it and clip it into the circuit. You don't need some fancy box like this. So I think they were probably more often used in laboratories or for demonstrations or for training. situations. But I don't really know because I wasn't around back when these were used. And when I was in college in the 90s, we didn't use stuff like this. Not that I remember. We had breadboards and we'd hook up a potentiometer to it, or we'd just stick discrete components into the breadboard and hook it up, or solder them together. We didn't use boxes like this. But I kind of remember using them in physics labs at points, maybe to do experiments with electrolysis or something like that. So I'm curious if any of you have experience with these. Where and how were they actually used? Now this one is a decade inductor, a DI-1 made by United Transformer Company in New York. It's 0.01 henries per step. So this goes from 0 to, now it says 0 to 10, but if it's 0.01 per step, and we have 10 steps, I guess that's 0.01 and that's 0.1, so 0.01, 0.02, 0.03, 0.04. We use our imagination. Very nice action on that. And again, your two connectors. Oh, here we go. I didn't notice that before. So this has been tested with 0.1 volt and 1 kilocycle, and they measured the inductance. 0.00497, 0.02 something's pretty worn out, and finally we have 0.09952. That's 5 digits of accuracy, or 4 digits of accuracy. I'm curious what they used to. They could have tested it to that degree of accuracy back when this was made, or were they just interpolating a bit? Rather neat pointer on this too. It's an arrow, but only one side is filled in. I'm used to seeing the Cornell-Dubilier ones. I have never seen that company before, but these are relatively common, especially the resistance ones. So let's see, these are both the same. Yeah, these are identical. CDB5s. CDA5, well, this goes much lower in value. This goes down to 100 picofarads and up to 0.01 microfarad. But otherwise, same deal. It's much smaller in value. So that question, troubleshooting with this for another reason. You use 100 picofarad, but then you're attaching leads to this and then clipping it into a circuit some distance away. The leads are going to add capacitance. It's going to pick up noise. You have the internal wiring, so I don't know. How were these used? Now this guy is electrolytic, 10, 20, 40, 80 microfarads, 450. This I could kind of see being useful if you suspect a filter cap is bad, or you're designing an amp and you want to know what's the minimum microfarads you can get away with. You could engage different caps and hear how much hum you're getting, that kind of thing, or measure it with a distortion analyzer. Or again, just tack solder a cap into the circuit rather than use this fancy box, but that's what this does. 4 caps inside, and you can engage one or all. Another decade inductor, type 702 teletype. High core. Again, henries times 0.1, or the other one was what, 0.01? Does it go 0.1 to 1 henry? Instructions on the back. 2% accuracy. And of course there's a maximum amount of current. So all of these things, they specify if it's a resistor, the max wattage, or inductor max current, or caps max voltage. You certainly won't want to burn these out. Here's another capacitor decade. I didn't realize these have it on the back too. So 5% accuracy. And I suppose another thing these were used for is maybe to calibrate test equipment. 5% these days is not exactly accurate, but in the 50s I imagine that was fairly good. Decade resistor, these are 3% accurate. 10 watts max. Here it goes 0 to 1K, and this is 0 to 10K. So on a 3.3K resistor, you put it on 3K, 300, there you go, 3.3K, up to 10 watts. This is kind of a boring one, just capacitor, 1 to 10 microfarad. You only get one control. But 3% accurate for an electrolytic 600 volts. I'm kind of curious to see what's in there, because if these are electrolytics, 3% accuracy seems unlikely. Doesn't weigh a whole lot. So let's pop this guy open in a moment. See what's actually in one of these. Resistor 2 watts. This goes up a bit higher. This goes from 0 to 1.1 meg. 1% accurate. Nice. That's more like it. And finally, another one of these guys, 1 to 10 microfarad. And I'm guessing it's polarized because of this, which makes me think it is an electrolytic. But where do you get 5% accurate electrolytics? And this was just hand selected, which is entirely possible. Date 046. Dates. I can't. That doesn't even look like a number. Looks like somebody's initials. But I would be curious to know. Maybe inside we can see some manufacturing dates on these. Otherwise, yeah, I'm not seeing date scratched out. Date 039. I don't think this is from 1939. I'm not saying it's impossible, but let's pop a couple of these open. Looks like you can either do it from the front or possibly the bottom. I'd rather do the bottom if possible. There's screws behind these feet, so I'll start out by trying to take the bottom out and see how that goes. As I started taking these apart, I noticed this one has experimental test lab on the side. Very professionally done, which makes me wonder, was it sold like this? Did Cornell-Dubilier use it for their own purposes, or was it sold like that, or did somebody do it after the fact just that neatly? At any rate, let's see what's inside. So this is the one that goes from 1 to 10 microfarad, 600 volts. So I was wondering, is it electrolytic because we have a red and a black? No, it is not. And these are much newer caps than I was expecting to see in here. So these are 1 microfarad, no, sorry, 2 microfarad each. How does that work? 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7. There's only 8 of them. But wait a minute. We have 10 positions, 11 if you count 0. How does that work when we only have 8 caps? These sure look like they've been well, I think they've been replaced. Or just maybe it was made rather sloppily originally. Whew, I would have to trace out the wiring on that. It's not what I was expecting to see. So one, these are newer caps than I expected. They're made by, looks like somebody else rather than CDE. And I thought it would just be a 10 position rotary switch, or 11 position with 10 active positions and 10 caps inside. But no. To do some mental gymnastics to figure out. So if we have 2, assuming these are all 2, if you put 2 2s in series, you get 1. If you put 2 2s in parallel, you get 4. So with combinations of all these being in series and parallel, we probably can get 1 through 10. And individually they are rated for only 400 volts DC. So if you wanted to say put on the 2 position, it can't just be one of these. It have to be 4 of these. So 2 in series to get 1, and then 2 others in series to get 1, and then put that in parallel to get 2, and get that 600 volt, well actually it'd be more like 800 volt rating. That's really weird. Oh man. Not what I was expecting. What makes me wonder, is that actually what was all about, or did somebody repurpose it for something else? So let's pop open another one. And that one was suspect because it only had 1 foot left on it. And it kind of looks... The insides look newer than what I would expect based on this. Based on the rest of it. These caps look like they might be from the 70s or even the 80s. But everything else on this looks like 50s or maybe 60s to me. Okay. Ooh, well, that's different. Rather ancient looking piece of cardboard. Okay, now that that looks it looks older, it looks messier, it also looks like maybe it's been tinkered with. Oh boy, again, this is not what I was expecting. Cardboard, there's a wooden block in here. We have Sprague, we have Mallory. Different manufacturing types, different style, case style. Wow. Now I see a whole bunch of J-hooks, so this has definitely been reworked. Man. Nice if at least one of these was still the original. This is 10 to 80 microfarad with some throw switches in. Now the guy I got this from, or the estate this came from, he worked at it was Bell Labs. He was a scientist, engineer, machinist, jack of all trades. So I could definitely see him maybe getting these from work, and maybe he was pretty handy. He definitely kept his equipment running. Maybe he recapped these or repurposed. Okay, this is more like what I would expect to see inside if these were the original. These are all Cornell-Dubilier. At least 4 of these are. This guy... Oh, I never saw one of these before. Or it's Industrial Condenser Corporation. That I've seen before, but... the name on this, let's see if I can pronounce this. It's a royalitic. It's a royalitic capacitor, long life, and nice cursive letters. It's a royalitic electrolytic capacitor. Ooh la la. I'm looking for a date code. So whether this was original or not, I don't know. But I bet these others are. It's 4045, 40 microfarad, 450 volts. I don't see anything else on these. 1045, 10th week of 1945, 40th week of 45. It's not impossible. It would have been, the war would have still been going on a bit. Piece of cardboard on the front. Huh. Well, let's keep on keeping on and check out some of these others. Let's check out one of the resistive ones. Rattling around in there. So, Cornell-Dubilier, Electronics Division, Federal Pacific Electric Company. Fuquay Springs, North Carolina. So were they bought out by Federal Pacific Electric Company? They became a division of them? I think they still exist to this day, but they're part of Vishay, who sort of took over everybody. But they are an American company. I always thought they were European, but I do believe they are American. They now own Sprague and Omite and a lot of the other classic brands. You know, they still make a lot of old-timey looking parts. You can get vitreous enamel power resistors from Omite. Still made. They reintroduced the Sprague atom capacitors. I guess we're going to take out these as well. One thing I'm bummed a little bit about Vishay is that they did phase out Mallory's axial plastic film caps, I believe. Alright, now this I expect is all original. Ooh, that's what was rattling inside. Got a little problem on this guy. Could be physical damage, could be overwattage, popped a little bit and roasted and expanded and popped. That's not what was rattling around inside though, that was just a little bit of... Oh no, there it is, sorry. Yes, that is very much what was rattling around inside. There's also a little bit of plastic in there, but yeah, there is the chunk of the coulomb that broke off. So again, a lot less than I was expecting. Really just 8 resistors in here, but we have two banks of controls, both with 11 positions on them, 0 to and so on. Oh, I would have to. It's been a while since I've done some network analysis circuits. So, can you take 8 resistors rigged up with 2 switches with 11 positions and make all this work? Apparently so. And let's see the values. So there's a 100 ohm, 2K, 3K, 4K, a 1K. So we have 1, 2, 3, 4, and then 100, 200, 300, 400 ohms. I suppose so. So if you have a 100 and a 200, that'll give you the 1, 2, 3. And then we've got a 4, right? So then 4 plus 100 is 5, 4 plus 2 is 6, 4 plus 3 is 7. And then, yeah, alright. Alright, I believe it. Alright, let's pop open another couple. Now I have another identical looking 1 through 10. This one does not say experimental test labs, but we can see, is it full of those yellow caps or is there something else inside? Let's see, are they the same model? No. Well, they're the same model CDC. This is 5%. This is, what I'm about to open is 3%. Curious. So you ordered the model, could you specify what accuracy you wanted? You would cherry pick one that was more accurate, if that's what you wanted. Maybe. Yeah, it is the same inside. It is the same. Now, maybe since the same owner had these, maybe he recapped both of them. Or maybe that is how they were made. Well, this one goes pretty small. This one goes down to 100 picofarad. We have 2 ranges here. So let's check out what's in this. 5% accuracy. So say you were designing a radio circuit, you really couldn't use something like this. The values are a little too much, and with the lead length and all that, you'd definitely be more like old school breadboarding when you get a hunk of wood and drive some nails or screws into it and solder parts together, keep the lead length short. Ooh, this is very different. This is more like what I was expecting. Rather than that crazy hodgepodge and the other one of all, rather than this looks more original. These are Priel silver mica caps. 1, 2, 3, 4, and then probably 1,000, 2,000, 3,000, 4,000. And they are actually made by Cornell-Dubilier. Very clean looking inside. And since they're silver mica, I bet it's held up pretty well. Alright, let's do one last one. This is another, it's the same thing. Let me maybe pull out one of the variable inductance ones. Nah, let's check out this guy. The variable inductance ones are the ones with Henrys. It's just a tapped inductor. There's really not much to look at. I took a quick look inside one of them. Just a transformer with taps. with a bunch of wires coming out of it. It's not a bunch of individual inductors. So this is another variable capacitance, but much larger, from 0.01 up to 1 rather than 0.0001 up to 0.01. Good indicator, might all be original. No. Again, crazy hodgepodge. A Sprague orange drop. We got an Aerovox or Ajax. We got Mallory. We got a black cat. It's like somebody went through their junk box and we got stuff paralleled up, and it's rather ugly, rather crudely J-hooked and whatnot. Who knows where this thing came from? It's covered in tar. Huh. Well. So, they are what they are. I really don't know that they have much value. They look cool. It's some historical significance. If I was going to use these, I think at least these ones that are really ugly looking, I'd put all new caps in here. But again, I don't really have a use for this, and I'm not sure what they were used for. But hey, there they are. Hope you found this interesting, and if you have any idea how these were used, what these were used for, or if you have any info to share, experiences to share, please leave a comment. Thanks for watching.